fundamental identities and periodic properties. Recall that if P is the point on the unit circle means x squared plus y squared equals 1, radius 1, corresponding to angle theta, then we define sine theta by y, cosine theta by x, tangent theta is y over x when x is not equal to 0. Now we can define the reciprocal identities that we've seen before. A reciprocal of sine is cosecant. Cosecant is 1 over sine. Secant is 1 over cosine. And cotangent is 1 over tangent. Similarly, we can find quotient identities because tangent is y over x, and that's sine over cosine, and tangent is cosine over sine. Now let's move to Pythagorean identities. We know that x squared plus y squared equals 1 on the unit circle, and x is just basically cosine. So this is cosine squared theta, that's cosine theta times cosine theta, plus sine squared theta equals 1. Or we can write sine squared plus cosine squared equals 1. For this equation, now we can do a couple of manipulations. We can divide both sides by x squared, then x squared over x squared 1, y squared over x squared, that's y over x quantity squared, 1 over x quantity squared, which is in terms of trigonometric functions 1 plus y over x is tangent, so tangent squared theta, 1 over x is just reciprocal of cosine, that's secant. Okay, instead of dividing by x squared, we could have divided by y squared. Let's see what happens. Y squared, x over y quantity squared, y squared over y squared 1 over y quantity squared. That is, x over y is just cosine over sine, that's cotangent. So cotangent squared theta plus 1 equals 1 over y. Y is sine, 1 over sine, that's cosecant squared theta. Okay, somehow we need to know these three, and these are easy. Okay, or memorize these formulas. Now let's go for periodic properties. A function f is called periodic if there is a positive number p such that whenever angle theta and theta plus p both are in the domain, and the following is true: f of theta plus p equals f of theta. Okay, and if p is the smallest number, then we call the fundamental period of f. For our trig functions, what happens is sine theta plus, when we go 2 pi, we are back to sine theta. So sine has a period of 2 pi, and same thing for its reciprocal, which is cosecant. And cosine, same thing, cosine theta plus 2 pi is also cosine theta, but for tangent it's shorter. If we go only pi, then the values will be the same, tangent theta. And this is similarly for cosecant, same as sine, secant same as cosine, cotangent same as tangent. Now let's go for even odd properties of trig functions. Even odd properties. Okay, cosine is an even function. That means cosine of negative angle is same as cosine of that angle, and this applies to its reciprocal secant. But sine and tangent are odd functions. That means sine of negative theta is negative of sine theta, and that applies to its reciprocal. Cosecant of negative theta is just negative cosecant theta. Tangent of negative is negative tangent, and cotangent of negative is negative cotangent.